Good morning, everyone. I am Shashikaran, working as an assistant professor in the Department of Electronics and Communication Engineering in Nagarjuna College of Engineering and Technology. And today I am going to give the presentation on the topic Coulomb's law. So, what is meant by Coulomb's law? The Coulomb's law states that the force between the two charges is directly proportional to the product of magnitude of two charges, and it is inversely proportional to the square of the distance between those two charges. So let us learn these things with a practical one. So let us take a charge and just assume that I am taking these charges in the free space. The free space means the medium is air. So if I have only one charge here, so the charge means whether it may be positive or negative, whether it may be electron or photon. So if I have only one charge, whether it may be of any sign, and if I take the one more charge here, okay, so if both of these charges are the like charges, means both are having the same sign, whether both are positive or both are negative, then the charges will repel each other, because as per the Coulomb's law, the like charges always repel each other, and the unlike charges means one charge is positive and another charge is negative, so then the unlike charges always attracts each other. So that is the concept which we are discussing in this Coulomb's law. So let us take this example here. So let us take a charge, one charge which I am taking it as Q1, the charge Q1 which I am considering here, and one more charge, let us consider it as charge Q2. So charge Q2 I am taking out now. So the force between these two charges is represented by the line here, okay, and the distance between these two charges is given by the R. So R represents the distance between the two charges. So now let us assume that both are positive charges. So both are positive charges, means both are like charges. If both are like charges, then the resultant force will be repel. So if we assume that the force of this Q1 falls on Q2, so the force of Q1 falls on Q2, so the resultant force will repel here, and we are going to get vector F12. So this will be the resultant force which we are going to get here. And so meanwhile, if the force of this charge Q2 which falls on the Q1, so what it is going to happen? So in this side we are going to get the force, that is F21. So what is this vector F21 represents is the force of Q2 which is falling on Q1. So that is what we are going to get with the like charges. Suppose if it is the unlike charges, means if we have a one charge with the positive sign, that is charge Q1, and another charge that is with the negative sign. So negative sign. So here we have different kind of charges, both are unlike charges. So now the communication between these two, the distance is represented by R, and now the force of this Q1 falls on this Q2, falls on this Q2. So what will happen? So the unlike charges attracts each other. So force of Q1 falls on Q2. Again the force attracts each other, and here we are going to get the vector F21. So why I am taking 21? Because now first the charge of Q1 falls on the Q2, and the resultant it attracts, and the force of this Q2 is going towards the Q1. That is what the vector F21 which I am getting out here. So in the same case, if the force of this Q2 falls on Q1, again it attracts, and it will be vector F12. Okay, so that is what the force which we are going to calculate in between the two charges. And now if we are taking the charges, so what is the difference between the vector F12 and the vector F21 is, so vector F12 is exactly the same with opposite sign of the vector F21, because the direction is different, exactly opposite direction which we are taking out. So that is what it represents here. Okay, so now as per the formula, so what we have discussed is the force between the two charges is directly proportional to product of magnitude of two charges. So force of two charges is directly proportional to product of magnitude of two charges. Magnitude of Q1 into magnitude of Q2 divided by, and it is inversely proportional to the square of the distance between these two charges. So that is what it represents, the statement of the Coulomb's law. So now to remove this proportionality, I need to add some constants. So that what constant I am going to add here is, so 1 by 4 pi epsilon. So why I am taking 1 by 4 pi epsilon only? Because so as the charges which we are taking out, it's clearly a three-dimensional one. So if it is a two-dimensional, so the angle, the total angle which we are going to get is a 2 pi. But if it is a three-dimensional space, then the angle it will be 4 pi. And why I am taking the epsilon? Because this epsilon is clearly the permittivity of the medium. So which medium we are taking out the charges, that plays a major role here. So that is what epsilon. So as we are taking the air, so based on that, the epsilon value is going to change. And apart from that, so it is multiplied by the charge q1, q2 and r square, and it is multiplied by the unit vector ar. So why I am taking the unit vector ar? As because the LHS is the force vector F12 which I have. So it is a vector quantity, and here the right side whatever I have 1 by 4 pi epsilon r q1, q2 and r square, it's clearly the scalar quantities. So just to justify with the LHS, so here I am considering with the unit vector, that is vector ar, and the unit of force which is represented by newtons. So that is what the Coulomb's law which we are taking out here. So that is the force between the two charges always attracts each other when they are the unlike charges, and if it is the like charges, it repels each other. Thank you.